All right, well, welcome back to, last couple weeks of first semester. We're going to continue on chapter 6, which was kind of factoring, is what chapter 6 kind of started out to be kind of before break. So hopefully you remember the factoring part. If not, go through and watch 6.1 and 6.2 again. We're going to start section 3 today of the chapter, which is really just special. Different types of things to factor. So it's really kind of a nice way to kind of get back. Kind of the nice thing about factoring in these special ways is that it's a shortcut. You can use the shortcut. You don't necessarily need to use the shortcut. You can use the X method that we talked about before, and it works both directions, and you still should be okay with doing it really either of the ways. So let's kind of take a look at what we're going to do. We're going to talk about factoring differences of squares, factoring perfect square trinomials, factoring differences of cubes, and factoring sums of cubes. So 4 different things first. So we'll start out with factoring the difference of squares. So we're talking about factoring differences of squares. We're talking about both of our x value and our y value being perfect squares, meaning that you can take the square root of them. So like 25, 16, 9, x squared, x to the 4th, x to the 6th, x to the 8th. Any even number x value is a perfect square. So when we're talking about differences of squares, the formula that we're going to use, and kind of the fast way to do these, is x squared minus y squared is equal to x plus y times x minus y. How do you find x and y? Well, your x value, it's not going to work. So your x value, my pencil's not charged enough. My pencil's at 0%. So it's charging, I hope, right now, so that's not going to do me any good. So the x squared plus minus the y squared is just going to be in this form. How do you find the x and the y values? I find the x and the y values by taking the square root of each of them. So for example, if we're going to factor p squared minus 100, so the square root of p squared is p, the square root of 100 is 10, so it is a difference of squares. So since it's a difference of squares, we could rewrite it as p squared minus 10 squared, which is then p plus 10, p minus 10. And it's factored, and there's nothing left to do with it. And it's kind of a shortcut, and this always works when that first term is a perfect square and that second term is a perfect square. If they're not perfect squares, this doesn't work. They have to be perfect squares for 1, and they have to be differences of squares for 2. So it has to be a subtraction. Pluses don't work when you're doing these. Like with all in the second example, first thing you have to do when you're factoring is take out that GCF. So our GCF in this case is 2, so we can take a 2 out of there. When we take a 2 out of there, we're left with x squared minus 9. X squared is a perfect square, 9 is a perfect square, and they're being subtracted. So the square root of x squared is x, the square root of 9 is 3. So then we're going to have 2, we got to bring that 2 along, and then x plus 3, x minus 3 is what we have then as the solution for that. My pencil's up to 10%, so in like 2 minutes I'll be able to use it again. Okay, so again, in this one, first thing you look for is perfect to take out a factor. So we've got 9 squared minus 16 squared, b squared. But it's not, but 9 is a perfect square, 3, 16 is a perfect square, 4, a squared is a perfect square, b squared is a perfect square, and they're subtracted, so we're good to go. So the square root of 9a squared is not 3a. Square root of 16b squared is 4b. So then it's just 3a plus 4 and 3a minus 4b. And you're done with that. Now, I think we're back to working here for a little bit anyway. Now, again, the nice thing about these is if you don't remember these, you don't remember the special property, we can still use what we did before. In this case, our c value is negative 100, and we don't have a b value, so our b value is 0. So we need, because remember, it's a times x squared plus bx plus c. So there's no just x there, so we're just going to make it 0. So that's why we've got a 0 on the top. On the bottom, So then we need two numbers that multiply together to be negative 100 and add together to be 0. So you can still use the X method to do these, and that's kind of the nice thing about it, is it doesn't necessarily have to be, you don't necessarily just have to remember it. Okay? So what happens if you have something like this? We're not going to worry about too much about this, but they'll just simplify it and you can kind of see what it looks like. And really, that's your answer. Okay? What happens when you have a y to the fourth? Well, y to the fourth is a perfect square. Anytime you've got a variable to an exponent that's even, it's a perfect square. You just, to get the square root of it, you just divide it by 2. Okay, so then if we look at this, the square root of x to the fourth is x squared. The square root of 16 is 4. So this becomes then x squared plus 4 and x squared minus 4. Well, 4 is a perfect square, and y squared is a perfect square as well. So we can take this one and look at this kind of this second part here, and that second part is a difference of squares. So we could factor that part as well. In fact, we have to. And because it's a minus, notice the other one's a plus, and since it's a plus, there's nothing we can do with it. It's got to be a minus. So we can factor this second part of it as well. So when we factor that second part of that, becomes x plus 2, x minus 2. And now this is now completely factored as far as differences of squares. So it's got to be a little bit careful sometimes when you're doing these. So that's the first one. Factoring a perfect square trinomial. So a perfect square trinomial, and again, these forms work, and this one is awful hard to see sometimes. But if you can see it, it is helpful. It says that x squared plus 2xy plus y squared is equal to x plus y squared. It's the factored form. Sometimes this is hard to see in honest cases. And when I see something that's kind of this trinomial, I mean, you can look at it and say, okay, I've got this. What's the square root of my x? What's the square root of my, like, 49z squared? Square root of 49 is 7. So I can say, okay, it's 7z and squared minus 14z plus 1 squared. So now, because 7 times 1 is 7 times 2 is 14, that gives me that middle term that's 14. So since I've got that middle term that's 14, you can easily then say that this is 7z plus 1 and 7z minus 1 squared. A lot of times with these, I'm not noticing them right away. So I'm just going to go and say, okay, my top number's got to be negative 49, my A value times my C value. My bottom number is negative 14, because that's kind of my B value in there. So I need two numbers that multiply together to be positive 49. So negative 7 and negative 7. Negative 7 times negative 7 is 49, but then remember, because my A value was 49, I got to divide this by 49 and reduce to negative 1/7. So that becomes z minus 1 times z minus 1. So a lot of times when I'm doing these, I use this method instead. It becomes a little bit easier, especially if you don't recognize it. How do you recognize it? You take the square root of your A value, the square root of your C value, multiply them by 2, and if that's the middle number, then you can do it. And then they take the sign on. That's that middle kind of sign. Okay? So if we look at the second one, kind of try to do it the fast way. And it's kind of this long thing. If I take 9 times 64, that's going to be quite hard to do. Okay, well, the square root of 9 is 3. So I get the square root of 9 is equal to 3. The square root of 64 is equal to 8. So 3 times 8 times 2 is 48. So it checks off. So because it checks off, then the square root of this is going to be my first term. So 3a is the square root of that one. it takes that sign right there plus the square root of 64b squared is 8b, and then squared, and that's our solution. And you're done. It's kind of the fast way to do it. But again, you can use the X method to do this, but it can become, especially with that one, quite large. Okay, this type of question we're not going to worry about. We're not going to worry about factoring by grouping or that type of thing. So the next thing is factoring what we call differences of cubes. So differences of cubes, this is the method we're going to use. We're not so much going to worry about factoring them as much as we're going to worry about kind of expanding them. So this is a difference of cubes, and you need to write this formula down because this is one you're going to have to use. So x cubed minus y cubed, that's equal to x minus y times x squared plus xy plus y squared. This is considered to be a difference of cubes. So I could take the cubed root of x cubed and have a nice number. So like 8. The cubed root of 8 is 2. 2 times 2 times 2 is 8. Or 125. 5 times 5 times 5 is 125. That's a perfect cube. And then when we're talking about perfect x's, so you're looking at multiples of 3. So like x to the third, x to the sixth, x to the ninth, and so on and so forth. Those are perfect cubes as far as things go. And when you have two perfect cubes that are differences of cubes, you can find the cubed root of your x cubed value and the cubed root of your y cubed value, and you can put them in and write them kind of in this form. So again, you need to put a star by this, put it in your notes somewhere so you have it quickly when you're doing your assignment so that you can use this difference of cubes thing. So when we're going to factor then this polynomial, what the formula says is that we're going to go x minus y times x squared plus xy plus y squared. Well, how do we find the x and the y values? Well, in this case, we know that we've got x cubed. Okay, and that's essentially going to be, so in order to find this, what we need to do is we need to find the cubed root of it. So the cubed root of x cubed is just x. So that means here, I'm going to have an x. We also have to do the square root, or the cubed root, the cubed root of 1,000. The cubed root of 1,000 is 10. So then my y value, in this case, is going to be 10. So my x is going to equal x, and my y in this equation here, my y is 10. So that gives me x minus 10. Now the second part says I have to do x squared. So that's just going to be x squared plus x times y. Well, my x value is x, my y value is 10, so that's 10x. Plus y squared, my y value in this case is 10. 10 squared is 100. This then is my factored form for that polynomial. Okay? So you have to find that x value, you have to find that y value essentially, and be able to kind of solve. Okay, so let's see how they do it. So they go a cubed minus b cubed, which is the same thing. So that's x cubed minus 10 cubed, same thing that they did. Then they put the formula together, which is exactly what we had. Okay. Okay, so let's look at another one. So we can kind of do it our way. So the first thing we have to do is we have to take the cubed root of 8k cubed. The cubed root of 8 is 2. The cubed root of k cubed is k. So that's going to be kind of that x value in there. Y cubed, the cubed root of y cubed is y. So these are going to be kind of my x's and my y's. So it's x minus my y times x squared. So we have to take 2k and square it. 2 squared is 4. So that gives me 4k squared plus 2k times y, which is 2ky, plus y squared, which in this case is just y squared, and there's our solution. So it's all about taking now the cubed root and those differences of cubes when we're looking at these, okay? Sorry, let's go back here a little bit. Let me go back. Okay. So again, let's look at one more of these. Okay, so we got 27m cubed and n cubed. So we're going to start out by taking the cubed root. Oops. Let's delete. Oh, it won't let me delete it. Maybe it will. Oh, it won't let me delete it. So the cubed root of 27 m cubed. Cubed root of 27 is 3, so that's 3m. And then the cubed root of 64 n cubed. Cubed root of 64 is 4, so that's 4n. So then our solution is 3m minus 4n. Now we have to square this first value, so 3 squared is 9, so that's 9m squared, plus 3 times 4 is 12mn, plus 4n squared, 4 squared is 16, n squared. And there's your factored form of that perfect square, of that difference of triangle, differences of cubes. Okay? So there's differences of cubes. Now, you can also have the sum of cubes. It's really the same thing. The only thing that changes with the sum of cubes is the signs. So before we had x cubed minus y cubed, now it's x cubed plus y cubed. The form is the same. It's still x, y, x squared, y, but now the signs have changed. So when we're talking about the sum of cubes and they're added together, it's x plus y times x squared minus xy plus y squared. So the only things that have changed are these two symbols. In the difference of cubes, this was a minus, this was a plus. In sums of cubes, this is a plus, and that's a minus. So that's the only difference between the sums of cubes and differences of cubes. Otherwise, they're done the same exact way. Same exact way, 100%. Okay? So note that the second term of the binomial factor of the difference of cubes is always the same as the sign as the original polynomial. Okay? So if we're going to factor this polynomial, we're going to do this the same exact way that we did the last problems. Okay? 8's a perfect cube. 125 is a perfect cube. So we're going to take the cubed root of 8p cubed. Cubed root of 8 is 2, so that's 2p. The cubed root of 125 is 5. So it's a plus sign here. So that means I'm going to go 2p plus 5. And then I'm going to go my 2p squared, so 4p squared. But now it's a minus. A times b, 2p times, so that's 10p. Plus 5 squared is 25. And that's your solution. Okay, so it's done the same exact way. You just have to watch your signs when you're doing these. Okay? Same answer we got. So we got another one. So we got 64m cubed. So I'm just going to do this one. Cubed root of 64 is 8. It's not 8, it's 4. So that's 4m. Cubed root of 125, n cubed is 5n. It's a plus sign. So it's going to be 4m plus 5n. Now I have to square 4m. 4 squared is 16, so that's 16m squared minus 4m times 5m is 20mn plus 5n squared is 25n squared. And that's your solution. Okay. Or the sum of cubes and factoring the sum of cubes. The same answer we had. You do need to be a little bit careful. Always make sure you take out a GCF first when you're doing these. So if you look at 2x cubed plus 2,000, take out a 2, and then that gives you x cubed plus 1,000. So take out that GCF, the cubed root of x cubed is x, the cubed root of 1,000 is 10, so you get 2, it's a plus sign, so x plus 10, and then x squared plus 10x plus 100. Okay, so make sure you take that GCF out first, always, in any of these that you do. And there's more in there, but you're not going to get really that type of question. So here are the special types of factoring. Difference of squares, x squared minus y squared is x plus y, x minus y. Perfect square trinomials, differences of cubes and sums of cubes. Take a screenshot of this and have it handy when you're doing your assignment and taking your assessment on this, which we're going to have a quiz at the end of this week. So there is section 6.3, factoring special types of polynomials. We'll go on to 6.4 tomorrow. Have a great day, everybody.